So, our next speaker is gonna be Katerina Sheremet. Katerina is Flutter developer and Google developer expert in Flutter and Dart, WTM Switzerland ambassador. In her free time, she works on her own app, the Learn Flashcards, that is published on Google Play and App Store Flutter packages. So welcome, Katerina. Hope you are in a great mood. Hi.
Yes, it's morning Saturday at my place.
The same with us. And we have now 10:30 a.m. And what time do you have now?
It's 9:30.
Great. Katerina, please tell us what topic have you prepared for us?
Today, I am planning to talk about block state management and exactly about Qubit. It's the newest version of Flutter block package. And also, I'm planning to give some tips how to apply it in a production application.
Sounds great. Then once you're ready, just let me know and I will share the screen of your presentation.
I think I'm ready. And by the way, thank you for introduction.
Not at all. You're welcome. So I'm passing you the microphone and here you go. You can start.
Yes, I think I can skip this slide introducing myself because it was already done. Therefore, let's continue with presentation. This is agenda of today's talk. We talk about what is block. We talk about principles and rules of block. Then we have a look at Qubit block state management and have a look on the example implementation. And afterwards, we discuss some tips of using block in production application. Let's begin. So what is block? Block stands for Business Logic Component and was presented by Google at the DartConf 2018. And it was designed to allow the reuse of the same code base independently of the platform, web application, mobile application, or whether it's a backend. And in block, we send an event from UI to block, and block is basically a class where all business logic is happened, and afterwards, block sends an updated UI and new state. Block sends an updated state to the UI, and a new state is displayed. And block has some strict rules. Block is a class, and dependencies must be injectable and platform agnostic. No branching is allowed in block. You cannot write, if platform is Android, do this. If web, do that. It won't work like that. And there are some rules for the UI as well. Each complex enough component has a corresponding block. And components should send input as is. If we have a form, we use your types, for example, phone number in one field and the country code in another. We don't merge this on UI because it's already business logic. And we should send two events to block. And if we get data from block, it should be as close as possible to the output we are aiming to show. All modification should happen in business logic, in block. And when we talk about block, we usually mean Flutter block. It's a package that was designed by Felix Angelov, and it's a very popular package. It has over 5,000 stars on GitHub, and it's also Flutter favorite package. Flutter favorite, it's a program, and it means that this package meets certain quality standards and has been reviewed by a committee, which includes Googlers from the Flutter team and also Flutter experts. And Flutter block from version 6 has implementation of block that's called Qubit. And now let's talk about Qubit. We'll try to answer the next question. How to create Qubit, how to get updates from Qubit, and how to inject Qubit in widget tree, and also important aspect, how to test all this code. To implement Qubit, we need to know such components as block builder, Qubit, and block state. To have the whole picture, let's see how Qubit can be implemented in an advanced Flutter counter app. Advanced Flutter counter app has two buttons. First one increases counter, the second one decreases, and a text that displays how many times we pressed button, and another text that displays what was the previous action. When we initialize our Qubit, it's going to be initialized. Then when we press plus button, it's going to be increment. When we press minus button, it's going to be decrement. First of all, we need to add Flutter block package to the pub/spec YAML file, or otherwise we won't be able to use any of classes for Qubit. To create, let's create state. To create state, we need to create class counter Qubit state, and it's going to be our base class. This class extends equatable. Equatable is also a package that is able to compare states and make sure that state is immutable. Immutable means that the instance cannot be changed without creating a new object. We also need to use equatable to write tests. You'll see an example in next slides, because we need to compare our expected state and our state that we have. And equatable package, it's easy to use because what we have to do is only override props getter, where we specify properties that we'd like to use to compare instances. Our props getter has action and count properties. And for the advanced counter example, we need three state classes: counter Qubit initial, counter Qubit increased, and counter Qubit decreased. And counter Qubit initial and counter Qubit decreased will have the same implementation as counter Qubit increased, basically. Now we need to create Qubit. For this, our class counter Qubit has to extend Qubit class, where we specify a type of our state. Here you see we have counter Qubit state that we created before. And counter Qubit has a constructor where in super method we define an initial state. That is counter Qubit initial, which with the action initialized and count 0. And counter Qubit has also two methods, increment and decrement, where we change the state. To send the new state to the UI, we can use emit, a method of Qubit class that sends a new state to the UI. For example, increment method emits a counter Qubit increase state with action increment and count value increased by 1. And basically, in your Qubit, if you need to get access to your state, you just type state dot, and you can access to any parameters that you have. Now we need to get somehow updates from Qubit and to display it on the UI. And to get state updates from Qubit, we can use block builder widget that has builder function. And this function has context and state parameter. State parameter contains count and action here. It's our counter Qubit state. And it's a value that we need to display on the UI. And the builder function will potentially be called many times, and it should return just a widget in a response in a state. We cannot navigate from here. For example, if you want to show some dialog, if counter is less than 0, you cannot write in block builder, in builder function, if state is counter qubit decreased and count is less than 0, show dialog. You cannot do this because to navigate, you should use block listener, because it has listener parameter which is called only once for every state, and block builder is not suitable to navigate because builder called many times, and basically your dialog or your screen might be open a few times. Now let's talk how to inject counter qubit in widget tree to make it available to children. And we can use block provider widget. It's a Flutter widget which provides a block to each children. And it's used as a dependency injection so that a single instance of a block can be provided to multiple widgets within a subtree. In this case, block provider is responsible for creating the block, and it will also automatically handle closing the block. And by default, block provider will create the counter qubit lazily. It means that it will be created when our block will be looked up first time. And to override this behavior and make it available when app is created immediately to do initialization, we can use lazy parameter, and it can be set to false. And it means if we initialize, if we provide our block on top of the widget tree, it will be created and initialized when app has started. Now let's handle user input event. We have floating action button where we call method onQubit in onPressed handler. We call, to call method onQubit, there are two options. The first one is to use extension on context. We call context.read, then we specify the qubit method, qubit class, and then we call qubit method. Here we have context.read, counter qubit, and then increment method. And another way to get method onQubit is to use a block provider of context where we specify qubit and also methods that we need to call. To get access to qubit, we can use context.read also, and there is another extension on context. It's context.watch. If you are familiar with provider package, it basically works the same. If you don't need to listen to any updates from qubit, you can use context.read, what we basically need here, because on pressed it's just a button handler. Now let's put all the code together to see the whole picture, how qubit block works. A user pressed on floating action button, and increment method of counter qubit is fired. Counter qubit is a block class that stores the current state of the UI and also handles all business logic. Current value of counter is increased, and the updated state was emitted using emit method of qubit. On UI, we have a block listener that listens to the current state of counter. And when new value arrives, it's going to be displayed on the UI, because builder callback called every time new value, we get a new value. Now let's talk about testing. There is a package, it's called block test, and this package was also created by Felix Angelov, and it makes testing blocks and qubit easily. And this package is also compatible with Mockito. If you need to mock some dependencies, you can, in your block, in your qubit, you can use block test and Mockito together. And to test our example, we use a block test that creates a new qubit-specific test case with the description sequence of states. Then we have ACT. It's a callback, which will be invoked with qubit under the test and should be used to add events to qubit. We also have a build callback, and it's basically where we initialize our qubit that we want to use under the test. So, and in ACT callback, we get this block that we initialized in build, and then we can call methods on our qubit. And in our example, we called 2 times increment and 1 time decrement. Then we have expect parameter. It's iterable with our states, and it has values that we expect to get after we executed these methods in ACT callback. And in our example, because we pressed 2 times increment and 1 time decrement, we expect to have 2 times counter qubit increment with action increment and count increased by 1. And also the last one we called decrement. Therefore, we expect to have counter qubit decreased state. And it's the reason also why we need equatable package, because we need to be able to compare these instances, what we expect and what we actually get from qubit. If we are not able to compare instances, these tests will fail. So we need to use something to compare. You can use equatable package, or you can do it by yourself. All this business logic. And now let's talk about some block tips and Flutter block tips that you can apply in your production application. Each complex enough component should have a corresponding block, and it's a separation of concern design principle. It will make your code more readable and testable. So if you have a screen where you have different features, so basically every feature should have a corresponding block, a separate block. It shouldn't be just one block per feature. And now let's talk about immutability. To avoid mistakes and not accidentally change the state, for example, on the UI, the state has to be immutable. And immutable means that the state cannot be changed without creating a new object. In Dart, a class is immutable if all fields are final. The easiest way to make sure that your class is immutable to use immutable annotation. And linter will then prompt and highlight in the code where immutability is not followed. Here you can see example, our locale state is highlighted, and we also use immutable annotation here. And to fix the situation, all fields must be final, and we also can make a const constructor. And if you use const in your widgets, for example, const with a sized box, and also const with your models, it improves the performance of the application, because constants are not recreated each time. They are canonicalized at compile time and stored in specific lookup tables, from which they are later used. And another solution, as I explained before, is to use equatable package, and equatable is designed to only work with immutable objects, so all members must be final. And with equatable, there is no code generation needed, and all you need is just to override get props, where you specify parameters that you need to compare your instances, and it's also useful if you are planning to write tests. The next tip basically, every application has a few blocks that are needed across all application, which you initialize on the top of your widget tree. And some of the examples, it's, for example, block with user information, where the user signed or not, block with payment, where the user has paid, like premium, freemium, to show features. And you can define all the necessary blocks using multi-block provider, and then access the block using block provider of context or extension on the context. So instead of nesting block providers, as I explained, because code will be less readable, you can use multi-block provider, which has a provider property where you specify list of your blocks. And so it eliminates the need to nest different block providers, and code is more readable and easy to maintain. Also, in the Flutter block, there is such a useful widget as repository provider, and it is used as a dependency injection widget so that a single instance of a repository can be provided to multiple widgets within a subtree. One of the use cases where this is used, for example, error reporting repository. In release, you can report to Crashlytics or Sentry or to someone else, and in debug, you can print to the console. So if you need to navigate, you can use a block listener that has a listener callback, which is called only once for each state. So if you need to navigate to new screen or pop existing screen or show some dialogue, I think it's a right widget for you. And another one, it's a productivity tip. When you work with block, you need to create a lot of boilerplate code, for example, qubit, and also states. And if you use still version before 6, and you need to create event classes, and VS Code or IntelliJ can do all this job for you, because there is extension. It's called also block, and was created by Felix Angelov, and it helps you to create blocks and qubits for Flutter and Angular Dart application. Let's make a wrap up. In this presentation, we talked about block, its principles and rules. We've also had a look at qubit block state management, specifically how to create qubit, how to listen for updates, and how to inject and how to test it. We also discussed some best practices of using block in production application. Example that was provided in this presentation, it's published on GitHub. This is a link. Feel free to clone that project and play around. I've also added the same implementation with the same UI of advanced counter with a hydrated block, and example with Flutter block with version before 6. So you can compare and have a look, and basically hydrated block saves your state. And for example, if you start your application, because previously state was stored, it will be retrieved, and all information won't be lost. It will be available on the UI. And thank you. That's it.